We're going to talk about growth and decay today. Exponential growth and decay. Actually, today we're just going to graph. Oh, I don't know. You may not have graphed them. I don't know if you graphed them or not. I'm going to teach you an easy way to graph them, though. All right, so let me show you before I actually teach you how to graph it. And this is not usually a hard concept at all. Most students like growth and decay. Let me show you what the graphs are going to look like. Because there's something special about these graphs. Let's look at growth first. Okay. Growth. And if you think about something growing exponentially, what do you think that means? Bigger, faster, right? If you think about taking something to an exponent. So what happens, you see this little dashed line here? It's an imaginary line on my graph, but it's not really imaginary. It's a boundary. And I'm going to call that imaginary boundary line an asymptote. Asymptote. It never touches. So it can get closer and closer and closer and closer and closer, but it can never actually touch it. And if you think about it, that's kind of like taking a number and dividing it by 2. You keep dividing it by 2, it's going to get closer and closer to what? 0. Is it ever going to actually be 0?
No.
No. Theoretically, you could continue to cut it in half and cut it in half. So it's this boundary that it's getting really close to. It's approaching, but it's not actually touching. So growth is going to look like it's going to hug this asymptote, and then it's going to start increasing very fast. Okay? Now it can look like this, and this is where it gets a little sticky. It can also look like that. Remember, normally we have a number in front of the equation, and when that becomes negative, it causes the graph to flip. Okay? So this is a negative leading coefficient and a positive leading coefficient there on the left. Okay? So the only new thing really here is that asymptote that it's hugging that's keeping it from crossing over. All right, so growth. And then we have, what you laughing about, Shami? Decay. All right, again with the asymptote. Let me put it actually. I know why I came up so high with it. And it's going to start decreasing really fast. This is one where, like whenever we said a minute ago, cutting in half and in half and in half. If you take 100 and cut it in half, that's down to 50. That's pretty small. And then half again would be 25. That's not quite as big a jump. And then 12 and a half, and it keeps going down. So then it starts to hug that asymptote there at the bottom. It can also be flipped. In which case it would look like that. I think he's trying to send you a message, Landon, in a cough. Exponential growth or decay, and this is why I do these both together. Both have the same form, okay? We've still got this A in front, okay? And A always has to, remember when we were talking about quadratics and we were talking about it was skinny or wide based on A?
What's H mean?
I'm going to tell you in just a second. Well here, A always in front is our shrink and stretch factor, okay? That's what it's going to do. It also determines if it's up or if it's flipped down, okay? So that's our A there. Now the base, which is the B. Now remember, if A is not there, what is it? Close.
1.
It's 1, okay?
Yeah.
Now my base tells me whether I'm growth or decay, all right? If my base is greater than 1, then I'm growth. And if it's less than 1, and I say less than 1, but it can't be negative, because the A out front would be negative if it was negative. So I'm talking about just this base here. So I'm talking about fractions, right? Fractions less than 1. What in the world? My pen quit. There it goes. The number on the end, which is your K. Now, if it's not there, what do you think K is? 0. This time I'm adding or subtracting. When you're multiplying and it's not there, it's 1. When you're adding or subtracting and it's not there, then it's 0. This is your asymptote. And it's always a horizontal asymptote. I should put that in parentheses. Horizontal.
What is that word saying?
Asymptote, in parentheses,
Oh, yeah.
horizontal. And then you can always rest assured that one point on the graph, and an easy point, I should say, easy point, is H, A plus K. Now notice this minus sign, so this H has got to be opposite sign. So it makes graphing a little bit easier as I go through. So if I know my asymptote, and it only takes 2 points to graph these. Asymptote, easy point, then you need one other. And we'll talk about domain and range too in
So
just a
opposite
second.
sign would be negative H?
Yes.
Why isn't it negative?
Well, because in the original equation it is negative H because it's minus H.
That's,
So the opposite would be positive H.
Opposite, what is?
It's just because whenever you see it,
what's the opposite sign? Where did you get H from?
this equation right here.
And then A. What?
Here's A,
Okay.
and here's K. Here's
Is
H.
that the under opposite?
Under opposite sign.
Okay.
Then it would be negative.
Let's say, let me give you a few.
All three of them different, huh?
Mm-hmm. Here's what I want you to do. Let's talk this through. I want to know if it's growth or decay, above the asymptote or below the asymptote. I want to know what the asymptote is and what an easy point might be for the graph. Okay? So let's think through that. I asked you 4 questions. The first thing I asked, is it growth or is it decay? Why?
Under 1.
Less than 1 here. Ignore the negative. The negative is A. That means your A is negative 1. Okay? So I know it's decay because my base is less than 1. Okay? What is the horizontal asymptote? Negative 5. Be confident. Be confident. I should put that.
Negative 5.
With the graph, since this is decay, think about what decay looks like. It's either going to come down and hug the asymptote this way, or it's going to be below the asymptote like that. Is this one above the asymptote or below the asymptote?
Below.
Why?
Because there's a negative
A is negative, so that means my graph is going to be below. And finally, what is an easy point to graph for this?
1 something.
Close. -1. -1. Yes,
-1 plus -5.
which is -6. H, A plus K. Does that confuse anybody? Okay. Look at the next one. Growth or decay?
Okay.
Growth. Why is this one growth?
B is less than 1.
Never mind. I'm done.
B is less than 1.
Greater than 1.
-2.
-2 is your A. You're looking at B.
Oh, I thought that was -2.5.
What's your horizontal asymptote? 3. What's or is it above or below the asymptote? Below. And what is an easy point on your graph? 0, because H is 0.
H.
1.
H, A plus K. One more. Last one. Is it growth or is it decay? Decay? Why is it decay? Less than 1. Above or,
Where's A? A 0?
No, what is A?
1.
1. A is missing 1. I forgot the horizontal asymptote first. Horizontal asymptote. 0. It's not there. It's 0. Above or below? Above. Easy point. Close. 2. H is first. 2.
Wait, where now?
A plus K. Close. 1.
1.
B is a half and A is 1. Are we all on the same page? We'll do a couple more.
I'm still not good.
If the A is negative, it makes it flip. So it would be below. If the A is positive, it's above. Other questions?
Still not good with easy points.
Okay, let's do a couple more then. Okay, tell me when you're caught up. That's it, Sharmeek. That's it. First one, growth or decay?
Wait.
Wait. Whoa, what? Wait.
I'm writing it.
Okay. Tell me when you're caught up.
Okay.
Okay. We said growth. Because B is
4.
4. Above the asymptote, below the asymptote? Above.
Because it's positive.
Speaking of, yes. Speaking of the asymptote, what's the equation of the horizontal asymptote? And easy point.
0.
0 and
Yes. Why is it 1, Tanner?
A.
A is 1. Don't let that fool you when you don't see it there. How about the second one, growth or decay? Growth. Because B is bigger than 1? Above or below?
Whoa.
What is the horizontal asymptote?
2.
What's an easy point? I heard 1, then I heard 0.
And a half.
0. 2.5.
5.
Over 2.
Oh. So like you could say then?
H.
Oh, yes.
Last one, growth or decay?
Wrong.
Decay. Why is it decay? Look at it carefully.
Because H is negative.
No. What determines growth or decay?
It's less.
The B.
The B. The B is less than 1.
And it's,
Above or below? Oh, I did 3 aboves. So horizontal asymptote.
2.
I did 2 2s? Easy point.
3.
What?
What? Opposite H. And then A plus K. 2/7 is your B.
Oh, they're 1 from 2.
You with me?
I need to start
Okay.
drawing one else.
2/7 plus 2 is not equal to
2/7 is your B.
Oh, 1 plus 2.
A is 1. Y'all ready to graph them? You've done all the hard work now. Yes, Miss McGee, we're ready. Oh my goodness. Could y'all be any more dead right now?
I got it.
Yes.
Oh my goodness. Y'all just have 4 days off.
Well,
I actually put on that line to you.
Let's graph. Before I graph, is it growth or decay?
Growth.
Growth, because 5/2 is 2.5, which is bigger than 1. Is it above or below the asymptote? Below. The negative is associated with A, not B.
Dang, I keep forgetting about it.
All right, so let's
put
graph.
negative A in there.
Do what?
What?
A would be -1. Anytime there's a negative out front, it goes with A. First thing I want to do is graph the asymptote. I'm going to put HA. Everybody knows what that means?
Yeah.
What is the horizontal asymptote here?
0.
0. Y equals 0. So it's actually on the axis. And we said it's below, so I'm going to come up here like this. All right. Dotted line for my asymptote. Nice. Do your easy point. Told you y'all done most of the hard work for this. 0, -1. Now, I know I need another point, okay? Because I know what these graphs look like. Either it's going to come up and hug the asymptote this way, or it's going to come up and hug the asymptote this way. So I need another point to give me that direction.
Plug it in.
Plug it in. What do you want to plug in? What do we always do?
0.
Easy point close to whatever you started with. I started at 0, so I'm going to stick pretty close to that. Remember, growth and decay gets really, really big really fast or really small really fast. So the further you veer away from that easy point, it's going to get big or small. I'm going to plug in 1.
Why is it? Why did you plug in 1?
Because it's really close to where I started at 0. All right, so we said we plug in 5/2 to the first power, which is, why is it doing all that? Go away. -5/2, which is -2.5, right? Shamik's with me. Okay. 1 -2.5.
How did you get the Y?
Plugged it in this original equation. 1. Now can you tell which way it's going to hug? Sure. It's going to come up like this, and it's going to go down like this. You know, looking at these, what it's going to look like
Isn't
anyway.
that -2.5?
Yes.
Then why do you only have 1 there?
What?
Oh,
This was 1, 2.
because then it'd be 2.5.
1, 2.5. You got it? How about the domain on this function? Come on, y'all. Domain. Negative infinity. Infinity. Oh, why am I not recording? There it goes. Range is my y, yes? What's the smallest y can be? Negative infinity. And then it goes up to what? 0. Does it include 0? No, because that asymptote tells me I can get really, really close, but I can't actually touch. Recording? Why does it keep not recording? Okay. Let's do. Let's do one that's got everything in it. First of all, tell me, why does that not become 1 to the x plus 2? It's got an exponent hooked to it. Absolutely. You can't do that. Remember, if the exponents are the same, you can combine the bases, or the bases are the same, you can combine the exponents. But if neither are the same, you must leave them. So looking at this, what is my asymptote? 1. Is it going to be growth or decay? Somebody said it. Oh,
Decay.
yes again. Why is it decay?
Because it's smaller than 1.
My b is less than 1. Is it going to be above that asymptote or below that asymptote?
Above.
Above that asymptote because it's positive. What is an easy point on the graph?
2, 1.
Negative 2, because you got to do opposite sign. Negative 2 what? 3. 1, 2, 3. I need another point. What's something easy to pick? What'd you say? What's easy to pick? What's close to negative 2?
Negative 1.
Negative 1. Plug it in. This one's a little bit harder to plug in because of all my pieces here. The nice thing about staying close to your easy point, if you go 1 to the right every time, you're going to get an exponent of 1. So I get 2 times a half. That becomes an exponent of 1. Multiply before you add. And I get 2. So what are the coordinates of that point? Negative 1, 2. We said it was decay, and it definitely looks like decay. What's the domain? Yep.
So is 1 where the dotted line goes?
Yes, yes. That's the asymptote. Yeah, that's your K on the end. What about the range? Bracket Princey. Because it can't ever actually be the asymptote. So your range is always going to be either negative infinity up to your asymptote or your asymptote up to infinity, depending on if we're above or below the asymptote. Does that make sense? Do we need to do another one, or y'all good?
Cool.
Okay, let me give you your project and then